Hello, Lumi is here back again with another math video, and this time it's linear algebra. I said I was gonna do it a while ago, but I got lazy and distracted by entomology, insects. So now we're back to math again, and linear algebra specifically. The textbooks I'm reading right now is Elementary Linear Algebra by Anton, the 11th International Edition, and I've read through section 1.1 and 1.2 right now. So 1.1 was about systems of linear equations, and the second one was about Gauss's elimination. And this question specifically from 1.2 is about solving this linear equation, system of linear equation with Gauss-Jordan elimination, which is basically Gauss's elimination, which is the forward phase, where we put it on row echelon form. Then the backward phase, that's Gauss elimination. But for Gauss-Jordan elimination, we have a backward phase too, and that will put it into reduced row echelon form, which is then it will give us easy. So yeah, let's start. So first we gotta write it in an augmented form, augmented matrix. So 1, 2, minus 3, 6, 2, minus 1, 4, 1, 1, minus 1, 1, 3, and that's our augmented matrix. First, the forward phase, we gotta make all the leading ones here, and here, 1, and then all below it, these three, we make it 0. So let's start. First, we gotta get rid of the 2 and 1 here. We already have a leading 1, so we don't need to multiply this by a scalar or any number. So we first have row 2 and subtract from it 2r1, row 1. So we multiply row 1 by 2 and subtract it from row 2. And also then for row 3, we basically take row 3 and subtract the first row just without multiplying, just subtraction, and that will give us this matrix 0, 0, 2, minus 5, minus 3, minus 3, 10, 4, and 6, minus 11, minus 3. So yeah, and from here we gotta get rid of this minus 5. So we multiply the reciprocal, negative fifth, multiply this second row, and after that it will become 1. The leading 1 will be here, and then we add 3 multiplied by we add 3 multiplied by row 2 to row 3. So row 3 plus 3 row 2, and that will give us this matrix. So yeah, this is the matrix, and from here we also multiply it by we gotta have to have a leading one here, so we multiply it negative half, multiply row 3, and that will give us this will give us the same but with a 1. 0 0, it will become here 1, and here will be negative 9/5. So now we will start the backward phase of Gauss-Jordan elimination, and we will start by trying to make these three numbers 0. So how we do that? We will do that by first subtracting from the first row row 2 multiplied by row 2, and that will give us this matrix. So yeah, now we have this matrix. Let me add another page. Yeah, and now we got to turn these two numbers into zeros. So how we do that? We first take the second row and add 2 of row 3 into it. That will give us 0. Then for row 1 here, for this number, we just subtract from it row 3, and that will give us this matrix, which is 1 0 0 10 5 0 1 0 7 5 and 0 0 1 minus 9/5, and that's our reduced row echelon form. And from here we will just instantly get our values solution. For x1 it is simply 17/5, and for x2 it's simply minus 7/5, and for x3 it's minus 9/5, and that's our solution. We solved it. Okay, so for next videos I might dabble into physics a bit with university physics textbook, but for now I think I will continue with math. I will return to calculus and elementary number theory. Yeah, that's the plan. So see you guys in the next video. Goodbye.